let's go ahead and dive in and take a look at what Docker is. Now, Docker is already installed on your Dev ASC virtual machine. And Anj, if you can get that installed on your Mac, and it should install on your Mac, or on Kali Linux, you should be good to go, right? So one of the first things I'll say is Docker PS, right? So here's some commands that you can run. Now, Docker PS is very much like the PS, the process command that you can run on Linux. And it just shows you and when we run it on Linux, when I say PS on Linux, it's going to show me the processes that are currently running. And so you can see I've got my login shell here, the bash login shell, and then I've got the command that I just ran, which was PS. And so it captures that as well. And with Docker, it's the same thing. If you have Docker containers that are running, if you say Docker PS, it will list them here. And over on the left-hand side here, it's going to be container ID, the image, command you ran with it, when it was created, status ports that it's running on, and then any names, right? And we're going to see that tonight. We'll create some things with names. So this is a tool that you can use to create your own containers. Now, if you have containers that you ran, but that have stopped, or that you have manually stopped, you could say Docker PS-A. Now, again, we haven't started anything up here. We haven't created anything. So there's nothing running and nothing that was running that has stopped. And so Docker leverages a Linux concept that's been around for quite some time called C groups and then namespaces, right? And these allow us to create these little, think of a container as like its own little mutually exclusive, hermetically sealed little bubble in which your application is going to run. So let's take a look at let's take a look at a basic example here. And if you guys were to dig into module 6, you'd see this. And so we're going to create what's called a Docker file. And the Docker file is simply the file in which we're going to place the commands that we want Docker to execute when it goes to create our container, right? So here's one way that you can do that. We can say cat greater than, and we're just redirecting the output of whatever it was we wanted to type right here. And let me see here if I can drag. It's not going to let me drag that over. So on the side of the screen there, you would put from with a cap, all caps from, and we'll put Ubuntu : latest. I'll hit enter and do Control D. All right. So if you do Control D, that kills the little cat command there. Now, if we cat out Docker file, what's in the Docker file? Okay. It just says from Ubuntu latest. Well, what are we doing here? Well, if I wanted to create a container, an Ubuntu container that had the Ubuntu operating system in it, this is how I would create an Ubuntu container with the latest version of the operating system in it. That would be a container. So how do we build this? Super simple. We say Docker build. Now the -T is where I give my special name, right? What do I want to call this? So I'll call this Trav's Ubuntu. Right? I'll say : latest, and that's the name that container is going to have. And you'll see that here in just a second. So then I hit enter, and you can see here it's going to go through the process of building the container. It pulls down Ubuntu from the Ubuntu library. So this is something that will confuse learners initially, is when I say Docker PS, they think, well, wait a second, you just said that we built this container. Why doesn't it show up here? And that's because the container's not running, right? So we have to manually, at least the way we're doing it, we have to manually run the Docker container. And so maybe you're going to think, well, okay, does it show that it's dead, that it ran and it stopped? Well, no, because it hasn't run at all. In fact, to see it, we would say Docker images. In fact, I think if I'm not mistaken, you can say Docker ls. No, or maybe it's Docker images ls. I thought there used to be an ls option with Docker. But anyway, So you can say Docker images. And so you can see here, we have these two containers, right? So we've created, well, the one container, it's Trav's Ubuntu, that's our container. But we've got these two images here, right? The one is the original Ubuntu image, and the other is the one that I just created, the container that I just created. And so this shows me the different images. Now, how would I run my Docker container? Well, I could simply say let me come back here. I can say Docker run. Now I'm going to use -IT. And the -IT is going to allow me to have an interactive session with the container, and I'll get the command line prompt when we go to run this. And I'll say, call it Trav's Ubuntu :latest. And what is the command that I want to run? So this is going to run my Docker container, and it's going to give me an interactive session with the bash shell. And you can't see it over there, but there's a little prompt. In fact, let me see, give me 1 second here, because this is bothering me that it's not, let me see if I shrink this. There we go. Let's do that. Yeah. So I'll just stretch this out here. Actually, let me see. There we go. A little bit better. And I'm trying to get away from the toolbar. Okay, there we go. Much better, much better. All right. So I'm logged in here, right? And I'm actually logged in to the container that I just created. And so I can go ahead and say uptime or ls, right? To get a listing of what's in the current directory that I'm in. And pwd, what directory am I in? Okay. And so that's how easy, with a single line inside the Docker file, you can create an Ubuntu virtual machine, right? I'm sorry, Ubuntu container. So we create this container, and the idea being is that this could be running some kind of application for us. Now, how do I get out of this? I would just simply say exit. Okay, so let's say Docker PS. And you can see that nothing's running. Remember, I exited out of that Docker session, or that container session. So if I say Docker PS-A, there it is. Now remember, the -A is showing me the container images that were running, but are no longer running, right? And you can see right here, it even tells you status exited 17 seconds ago. Now, if I wanted to see the Docker PS, I would have to drop what I was doing when I go to do my Docker run. I would have to put it, detach it so that it would run in the background. So we could do that. So let's pull up that Docker run command. Whoops, right there. And we'll say IT, and I believe it's the D. Whoops. All right, so you can see I got my prompt back, right? Which is my Ubuntu Dev ASC virtual machine. And so it shows me this, this massive hash right here. But what happens when I say Docker PS right now? Well, there it is, because it's actually running, and it's running in the background, right? It's running in the background. Now, I could try to attach to this and, go back in on the command line and do something. But again, I just wanted to show you that that's how you would run it in. The D stands for detach it from the current terminal session and run it in the background. So if I was to say Docker PS-A, right, you can see that we see the session that is currently running as well as the session that exited out a while ago. So PS shows me only what's running. PS-A is going to show me if it is running, or all the containers that I've exited out of, right? Or that are no longer, that were running, that are no longer running, right? So those are two good commands to know right there. Okay. So let's do a level set right here. What questions do you guys have about about Docker And Docker containers, and again, just we're going to do a much more, we're going to ramp it up here and make it a little bit more challenging when we start to take a look at doing more than just the from command, right? Because again, this really doesn't do much for us other than start the container up. So does this make sense? Is everybody with me so far? All right, so Dylan or Christy says yes. Okay, good. All right, good, good, good. Okay, so again, all a container is a really trimmed down version of whatever it is you're trying, whatever application you're going to create, a web server, a database server, an Ubuntu container that we've created here. And so that's pretty much it. So now let's go ahead and take a look. How interactable is the Ubuntu OS when containerized? Yeah, I mean, you could do all kinds of stuff. Again, all I'm showing you is, hey, look we've got a container, we can get logged in, but you can do all kinds of stuff with that container. You can expose ports, you could run a web server on that. And so the example I'm going to give you now is going to build on what we've currently looked at so far. So good question though. So yeah, you could do all kinds of things with the container. Okay, so let's talk about what we would want to do with our Python app, right? And here's where we're going to talk about Flask. So Nginx, right, as I've mentioned Nginx, and that's like a pretty high-speed web server that you can run, right? Well, Flask is a web development framework for Python, right? It's inextricably linked with Python, super, super easy to use. And we can create, little sample type web applications by using Flask. And so I'm going to give you an example of that so that you can see how this might be done and how we could create a simple web app. So again, one of the first things you'll want to do, and I've already got it installed on here, is you would want to say pip3 install Flask. And you can see here it's already been satisfied, but that would get Flask installed on your virtual machine. So Anj, if you're doing this on Kali Linux or your Mac or whatever the case may be, you would want to make sure that Flask is installed. Okay, so the first file that we're interested in that I'm not going to actually have to type out is, let's go ahead and take a look at sample_app.py. All right, so here is, believe it or not, this is our sample app right here. And there's going to be some modifications here, I believe, because I think I've tweaked a couple things and I have. So we're going to make this, make some changes here. So at the top here, we've got a couple lines that are important, right? We need these Python libraries. So from Flask, import Flask, and then from Flask, import request. And this one here, I'm going to comment out. We don't actually need that for what we're going to do. So what we do here is what we've done before many, many times. And that is when creating a class in Python, right? What do we do? What is a class? A class is just an object factory, and it just pumps out objects. So here, we're creating an object from the Flask class, and the name that it's going to have is the name of the object itself, and we're going to call it sample, right? So sample gets the value of this new object Flask with the name, right? Or dunder name. And so all we're doing is creating an object, and that object name is called sample, and it's from the Flask web framework. So here on our first line, so here on the first line where you have the @ sign, if I come down here, right there. So this is what's referred to as a Python decorator. And the analogy that I always give is, you can think of this as the icing on top of the function cake, right? Because right below it, we've got this function main. okay? And so what this @sample.route means is if somebody is accessing the top of the web framework, the top of the hierarchy of the web framework, right? And that's what that / stands for, that we're going to go ahead and we're going to run this function. So when someone uses my Flask sample web app and they are going to, and the top of the web framework here is just like, think of it as like, oh, I go to cisco.com and I hit enter, right? And in most cases, you would expect to see like their index.html or index.htm or whatever it is they're using. And so that's all that / means. And it's kind of like the Linux file system hierarchy. Remember, at the top of the Linux file system hierarchy, we have that / that stands for the root directory, right? You're at the top of the file system hierarchy framework. And the same thing is true here. So we're saying when they type in http:// and for this, it's simply going to be localhost because it's running on the dev ASC virtual machine. So when we type that in and hit enter, it's going to do the following. It's going to go ahead and say, oops, sorry, let me get over here. It's going to go ahead and say, and we're not going to render the template. The render template means it would show a web page, but we're not actually going to do that. We're just going to have it print up this message that says, you are calling me from the IP address, and then that little curly braces there, that's our placeholder for the value right over here. And remember, you might be wondering, well, wait a second, request, where is that coming from? Well, remember, we imported that from Flask, from the Flask library. And request.remote_ADDR, that's an attribute that we can pull, and that attribute is going to be the address that the Flask web server thinks you're coming from. And so we just want to see that attribute value, right? Now, down here, we have if dunder name equals dunder main, then there's my object name again, right? Sample.run. So this first line, remember, this first line right here, this if name equals main, what that is saying is if you're running the program directly from the command line. In other words, I would save my file and type in Python3 space sample_app.py and hit enter. And when you do that, when you're running it directly, dunder name is dunder main, right? If this was being imported into another Python file, then this would not be, dunder name would not be dunder main, and then it would not run our object, right? So here's a method that's linked to our object sample from class Flask, and it just basically says, hey, run this web server, and the quad zeros, you can think of this if you guys were familiar with, remember back to Cisco Networking 101, the default route, right? And all that statement there means is host equal quad zeros is it's going to run this on every port that the system has that's up, right? That the process will run on every single port on the system, or every single interface on the system, sorry. And then the port number that I'm going to use is 8080. Now, again, that port number, I can choose by default, Flask uses 5000. I could change it to 5555. I could change it to whatever, right? As long as the port's not in use. But for the purposes of what we're doing, we're going to use port 8080, right? Okay, well, let's check and see if this actually does what we think it's going to do. So I'm going to save the file, and here's where I'm going to type Python3 sample_app.py. Now, very important to note, you can see right here, or you barely see right here, it's kind of in red, but it says do not use this in a production environment. And that's great advice, right? Because Flask is a development tool. It's not Nginx. Like if you're going to do this in production, you'd be using Apache, and you'll see you'll actually be you'll actually be creating an Ansible playbook that not only creates an Apache web server, but modifies the Apache web server config files so that it's running on specific ports. So you would do in production, you would use like Apache, or you would use Nginx, right? You would use something that is production ready. Flask is not. Again, it's awesome and it can do all kinds of cool things. It's just not for production deployments. Okay. So it says that it's running. Well, I'm not convinced. So let me drag this. Oops, sorry. Let me drag this over here. Trying to get so I can get to the arrow to iconify it. There we go. And I'm going to pull up the Chromium web browser. So pull the Chromium web browser up, because if it is in fact running http://localhost:8080, if that is actually running, the Flask web app is running, when I hit enter here, I should see the message telling me, let me slide this back over, there we go. And that's what I told it to tell me. You are calling me from the IP address 127.0.0.1. And no, I don't want to restore. Click cancel there. And it did it anyway. All right. So, and the 127.0.0.1 is localhost, right? So I'm actually accessing this website, or I should say website, this web page, the Flask web app from the local host. And so it's actually running, it's actually working. In fact, if I was to pull back up the terminal window here, we're going to see some interesting log information, and it shows you that it looks like it was looking for the favicon.ico, the little icon that shows in the upper, in the tabs when you hit certain websites with the company logo or whatever, and you get a 404 error there. But for the HTTP request, what did we get? We got a 200, and that's good news. That means that that was running. Now, that's how you would access it using the web browser to see, okay, well, what is it going to say? Well, let me see. I don't think we can dupe this, but let me do a new tab. And let's do, I'm going to have to do this a couple times, so bear with me here. Zoom in, zoom in. Let me zoom in one more time, and I think I can do it one more time here. Just trying to make sure that you guys are able to kind of see this a little bit better, because it opens it up with such a small, and I haven't created profiles. So we could say curl http:// the quad zeros :80, right? And we get this connection refused, failed to connect. And what we should have seen is, and actually let me do localhost. Why is it? Oh, I'm sorry. I thought I did the 8080 and I did not. So there we go. So I should be able to do, I thought I was hitting 8080 there and I was not. And so we want to do 8080. We can do localhost. You can do it with the quad zeros. And there you go. And in fact, there's even one more way to do that. You could come in here and you could say 127. I believe you can do 127.0.0.1, 7.0.0.1. So there you go. So there's 3 different curl commands that you can use to validate that the app that you set up is actually working, right? So pretty cool again. Okay, well, that's all good and all, but what if you don't want it to just, pump some text out? What if you're expecting, you want to have a web page of some kind? You can see the 3 curl commands I ran. There they are right there. They were logged right here with a HTTP status code of 200, meaning success, right? When we see the 200s, that's good news. 400s, bad news. All right, so now we're going to go ahead and we're going to do an index.html and a style.css. And the way that Flask works, and here, let me quit so if I just do Control-C, that's it. And now it's no longer running, right? So that little Python Flask web app is no longer running. Now, in the sample app directory, right, wherever it is that you're creating your sample_app.py Python Flask web app, by default, Flask will look into the templates directory, which you would create, and or the static directory for two types of files. In the static directory, this is where it's going to look, and this is where we get into some web lingo here, is it's going to look for your style.css file, your cascading style sheets file. And that's what allows you to put like the bells and the whistles on your HTML page. So you could do a background color and you could pick a font, and those are the things that you would do with CSS. And so by default, Flask is going to look in this directory for that style.css file. And if I was to say more, static, style.css, you can see and that's it, right? Body, and then inside the curly brace is background colon light steel blue, semicolon, and then close the curly brace. And so this is, again, because this isn't a web design class, so that is super bare minimum code that you put in your style.css file, but it's going to give us a light steel blue background on the web page, as opposed to what we saw here when we pulled it up. It's just, this white background, right? Not much exciting about that. So maybe we want to spice it up a little bit and go with a light steel blue background. And then if we look at our index.html and I say more on templates / index.html, so here's our index.html page, right? And what do we have? So we declare it's an HTML document, and then the header information is where we're going to have our title, right? So, and this is what shows up in the tab of the browser. And maybe sometimes you've seen this if you visit, you go to, I'm trying to think of where you go to DevNet, right? If you go to this, you pull up the DevNet course, it will say DevNet in the browser tab. So this title is how you would do that. And in fact, we'll change it. We'll have it say something else. And then right below that, this is the code that you would need to reference your CSS file, right? The light steel blue background. And that's what we're going to be using that for. Now, here's something that kind of throws users for a loop, and I'm going to kind of gloss over it. We're not going to get into the gritty details, but I put this in here. It just says, woot woot, and now it says you are calling me from, and here, this is where it gets a little bit confusing, is learners will see this and they'll think, oh, so that's HTML. And technically, that's not HTML, what I have highlighted right there. So what you see in between the double curly braces, and it's the double curly braces that are making this, it's called Jinja2, Jinga, and then the number 2. And Jinja2 is also a web framework tool. There's one called Django that does, Django's more popular than Jinja, I think. But again, and all it's doing is allows us to actually communicate with the Python code. And so here inside of the HTML page, this is what makes it dynamic. So irrespective of where the user is coming from, this is going to ensure that it gets their remote address every time. And it's very, very cool, right? But we embed it into the index.html page because that's the page ultimately that we're going to have displayed to us. And so again, this is just called Jinja2 is how this is doing this, right? And it allows us to have that request.remote_addr attribute, which is the remote address of where the request came from, the HTTP request, and it's going to display it. And it works with that Python file. Remember, a minute ago, we had that exact same code right here in our sample underscore app.py. Here it is right here, right? And so all we're going to be doing is we're going to be transitioning that code into the HTML document, our index.html, so that every time someone hits it, it doesn't matter where they're hitting it from, the index.html page will automatically, dynamically update and show us our information. Okay? So we've got to make a couple changes here. In fact, I should have VI'd the file. And so now we're going to come back and we're going to comment that line out. I'm going to uncomment this. Now this, again, remember, this is just a Python function. And I'm telling it to return, and we're going to render a template. And all render template means is, here's the HTML page I want you to show me. And by default, Flask is going to look inside that templates directory for that index.html file. So from your perspective, this is typically where a lot of confusion will come in, is either you don't put the templates directory in the right spot, in like right here in the directory that's with the sample app, or you put the index.html in this directory as opposed to the templates directory. And the same thing with the style.css. So when you're doing this week, if you're having issues, make sure that you remember that it's the templates directory where the HTML files go. The static directory is where the style.css file goes. And then we're going to change, we need this up here. Because we need, from Flask, we need to import the functionality so that we can render this template, right? So that we can display this index.html page. And so that's the only difference that we're going to be making right there. All right, so now let's save. We just saved our file. Let's clear our screen. And now let's go ahead and let's run our app again. And we're going to run it directly, Python 3, and then sample_app.py. And we'll hit enter. Hopefully I have no typos in there. And so this is a good sign, right? When you get here, this means, hey, okay, cool. My Python app is running. Remember, it is not a container yet. This is just this Python script that's running this Flask web app for us. Okay, so I should be able to pull my browser up, and I should actually be able to refresh, and there you have it. And so here in the tab, you can see it says sample app, and we know where that gets set. In the header, between the header tags, the title of the tab is whatever that title is. Now, here's something that's interesting. I'm going to go ahead and I'm going to click here, and we're going to go ahead. I'm going to come into this other window, in fact. So remember, it's still running. I never killed the app. So if I go into sample_app.py and I change, oh, sorry, not sample_app.py. I want to go into templates index.html. So if I go into the index.html file here and I change the title, let's change our title here in the index.html. I'll say my cool app. And we save it. If I go back to the browser and I click refresh, you'll notice that the title, it's tiny, I apologize, because Chromium, it's set to the default size. So it still says sample app here. So remember, any changes that I make after I've got the application running to that index.html page are not going to take place, right? They're not going to happen. So I'd have to quit the application. I would then have to restart the Python Flask web app. And now when I go back into Chromium and click refresh, you can see up here, it's my cool app. Okay? And so again, it's very straightforward. It's not very difficult in order to get the application running on your virtual machine. You could do the curl commands again and stuff like that. So here's where we're going to break. And this is actually a good logical breaking point here to take a quick bio snack break. Because what we'll do when we start up after the break is now we're going to tie this into what we just talked about. And that is, I mean, so let me ask you this. Can you imagine building a server from bare metal, buying the server, paying for the Windows or the, using Ubuntu for free, or paying for the Windows licenses, or however you're going to do it, building that entire server, putting that huge, messy, massive operating system on there to do this, right? So that's what we're going to be doing next, is we're going to containerize this application. And so we're going to get this application to run inside of its own little container using Python. And that's really all we need, because remember, the Flask web app is a Python web framework. So what questions do you guys have over what we've seen so far with creating a container, how easy it is to create a container? Again, the little Ubuntu container, we don't do much with it, but that's how you could create a container. And so now we're going to get into a little more advanced setup for a container here. Any questions? What do you guys think? Is it making sense what we're doing here? And remember, go ahead.
It makes sense. I guess I wondered, like, I have a little bit of experience with virtual machines. How do companies decide when to use containers and when a virtual machine is a better option?
Yeah, so that's a great question, Christy, and it all comes down to use case. So we have a ton of virtual machines, and I'll give you a great example. That's a really good question. So you have a really good example here. So we have Windows Active Directory servers, and we have two of them. You have primary and a backup, right? So if you're going to build out a Windows Active Directory server, you're going to do that on a virtual machine, because you need to have all of the Windows operating system, the server operating system, and all of that functionality, and we would put that onto a virtual machine. Now, when would I containerize something? You would containerize, and again, this is just one of a million different things that you can containerize. You could containerize a web application, right? Like a website that isn't supposed to be, like dynamically updating and all that stuff. You could containerize a web application. You could containerize a database application with Redis. Redis it's like a database application that's popular to be containerized. Nginx, again, you can containerize an Nginx web server. And so those would be like tiny things that you would want to containerize that aren't going to be called upon like a Windows Active Directory server. Does that make sense?
Yes, that does. Okay.
Okay. Yeah. And again, think of containers as like really trimmed down, because a container is only going to do and be outfitted with exactly what it needs to do, what you need it to do. That's it. Whereas like, an Active Directory controller, I mean, you've got, you may have federations going on and all this other stuff going on, and you would never do that. You would never containerize that functionality because it's just too much. So
Right.
and so we just build out Azure virtual machines, and that's how we do our Active Directory. And then our containers, we have like little apps that we work with from different vendors that we containerize their application. And so they give us the files, we build the containers, and then we actually have a Kubernetes cluster on which the containers run to make sure that if one node goes down, that it just moves over to a different node and continues to run and doesn't ever crash out. But yeah, really good question.
Okay. Thank you.
You got it. You're welcome. All right. Well, let's go ahead and grab a quick 10-minute bio snack break. We will regroup at 8:13. So we will come back at 8:13. And I'll pause the recording here, and I'll see you guys in 10. All right. So we've got the recording resumed. So you saw a Docker file, albeit a super, super simple example of a Docker file. And let me actually take a step back here. So, Christy, that question that you had asked about, when would you use the virtual machine? I didn't mean to imply that virtual machines are going to be going away anytime soon. So virtual machines are going to, prevalent everywhere. And the key word with a container is lightweight, right? It's doing something that's lightweight as opposed to like super heavy lifting, like an Active Directory server. So we're going to containerize. Obviously, when you look at this app that we've created, if we wanted this to be able to be run, on our system in Amazon Web Services or whatever the case may be, we can containerize something like this. So this is a great example of how we can containerize a super simple, lightweight application. So how do we do that? Well, in order to do that, we're going to have to create a Docker file. Now, this is what the course is going to have you create this file called sample-app dot, oops, sorry, not .py, sample-app.sh. There we go. Okay. And this is part 5 of lab 627. And all it's doing is having you put a bunch of the bash shell commands into a file, and you're creating a bash shell script so that you don't have to run these manually. And it's down here. And so let's go through these one at a time here. So these first 3, all we're doing is making directories. So we're making this directory called tempdir. And then inside the tempdir directory, we're going to create a directory called templates and one called static. And what do you think those might be used for? Well, we're going to put our index.html and templates and our style.css that we have in the current working directory. Those are going to get put inside that temp directory in templates and static. And so we create these 3 directories here, tempdir, and then inside tempdir, we create templates and static. Then we're going to copy the 3 files I just mentioned. We're going to copy our sample_app.py. That's our Python Flask web app, right? So literally that file, that sample_app.py file, that is our Python web application. And we're going to copy that into tempdir. And then we're going to do a recursive copy of everything that's in the templates directory, which we've already got created here that I showed you. And we've already seen the only thing in there is the index.html. So yeah, we could leave the asterisk here if we were thinking maybe we'll put some other files in there, but that asterisk could easily be in, just say index.html, because there's only one thing in there. And the same thing in the static directory, right? We're going to copy everything in the static directory into tempdir static. And the only thing in there is our style.css file. Now, here's the creation of the Docker file. And it's these echo commands that we're running from our bash shell script. And we're going to echo out from Python, and we dump that into the Docker file. And then we say run pip install flask. And this command right here that goes in the Docker file is just being appended to the Docker file. And then we're going to copy, and again, this is a command, right? In the Docker file, we're telling it, hey, copy from the static directory and put it in home my app static. And that goes into our Docker file. And then we're going to copy whatever's in the templates directory, and we're going to put that into home my app templates, right? And then we're going to copy our sample_app.py, and we're going to put that in home my app. And so what we're doing is in the home directory, we have a directory called my app, into which we're going to create, or we're going to copy all the stuff in all the stuff in static, which is the style.css, and all of the files in templates, which is just your index.html file. And we're going to put those into that home my app directory. And then this expose 8080 is saying we're going to run the application on port, or the container is going to expose port 8080. And then what's the command that I run? The same command that you guys just saw me run right before break when we ran this manually. And again, the home my app wasn't in there, but I was running sample_app.py. And so we are creating a Python web application using the Flask web framework, and we are going to containerize the entire thing. And this is, again, it's not very difficult, relatively speaking. It's not very difficult to come up with a Docker file to create a container that's going to run, right? It's actually pretty straightforward. Okay, so let's go ahead and build our Docker container. But before we build the Docker container, we have to have our Docker file. So let me go ahead and do this here because the temp dir already exists, I believe. So I'm going to say rm-rf /temp dir. All right, so in that command right there, be very careful with that command. That command is going to remove everything that's in temp dir, right? And that's what we wanted to have happen there. So now I can say /sample-app.sh. So let me run my bash shell script, and I didn't see anything happen here. And you could always check if you say echo $? I believe it is. Yeah, if you say echo $? That'll show you the exit status of the command that you just ran. 0 is what you want to see, right? Anything other than 0, and then something bad probably happened. Okay, so that shows me that it ran. Well, how can I confirm that that actually ran? Well, take a look at this. It created temp dir, and so let's go into temp dir and see what's in here. Well, lo and behold, there's my Docker file. There's my sample_app.py application file. There's the static directory with my style.css file in it. And there's my templates directory with my index.html in it. So I have everything in here ready to containerize this application using Docker. And how do we do that? We're going to say build, Docker build -t sample app dot. And the dot means that the Docker file is right here in this directory. It's going to look for that file, Docker file with a capital D, right here in our current directory. And the name, that -t allows us to specify the name. We're just calling it sample app. I'm going to hit enter and take a look at what's going to happen here. It's going to download the latest Python. It's going to pull down everything it needs. It's going to run that command. Remember, we had the run command in there for the pip install command in order to install Flask, right? Because we're going to need Flask installed in order to run our web server. And there it is, run pip install Flask. So it's given the steps, and there's no coincidence, and that's okay. You can ignore that. It just means pip needs to be upgraded. So there's no coincidence that we had 7 steps, and if I cat out the Docker file, right, there was 1, 2, 3, 4, 5, 6, 7. So each of those commands that was in the Docker file is just a little step that we had to do, right? All right, so I'm in the temp dir. I've got those files that are in there, and now I'm ready to run my container. So I've just created the container. So if I say Docker images, you'll see that we have my sample app, but remember, it also pulls down Python, right? It also pulls Python down. So we're under a gig, right? Under 1 gigabyte, and our app has been containerized. So now let's run this app. So how do we run it? We're going to say Docker run -t -d, right, to detach it, -p on the ports, 80, 80, 80, 80. And I'm going to circle back here. Give me 1 second. Name, and then sample running is our name that we're going to give it, and sample app. And in fact, here I could actually change this to, Trav's cool app, sample app. Oh, and I said Coker, so I'm going to have to pull this back here real quick. And it should be Docker. All right. There we go. Okay. Oh, it's already in use. Am I still running? Hold on one second here. Am I running? Oh, I am. Let me kill that. Forgot we left it running, right? So we left it running when we had manually started it. So port 8080 was already taken. So we had to come back and kill our manual running of it. And let's go ahead and do that right there. Whoops. Travis is already, all right. So I want me to rename it here. Hold on. Typos. So we'll just call it sample running. We'll do what they asked us to do the first time, and there we go. Okay, so what just happened is we created a container. We are now running a container, and the only job of that container is to run this Python web app. That is it. That's all this container is going to do for us, right? So what just happened in the command line here? Let me get rid of all of my errors, and let's pull this back up here. Okay, so we've got the Docker run command. The -T, again, says we want to create a terminal for it. The D, again, remember, that's going to put it into the background so that we get our prompt back. So it's going to run that in the background. The -P specifies the ports. So the second 8080 tells Docker to use that port on the host. The first 8080 is the container port that's being exposed. And so in this case, they're the same, right? They don't always have to be the same. You could do 80:8080, and then the container would be exposing 80, and then the host would be 8080. So, but we're just doing 8080 to keep them both there. And then --name is a name that we can refer to this container as without having to use the container ID. And as you're about to see, when we say Docker PS, because now we're running, where's that here? Yeah, sample running, right? If we didn't do that, we'd have to refer to it by its container ID. So sample running is a little easier to remember than the container ID. And so that's what just happened right there. And now our container is up and running. In fact, I think they show you the Docker PS-A. Again, you see all these things that were running or that are no longer running. And so that is it. We've exposed our container on port 8080. The host is exposing port 8080. So at this point, I should be able to go ahead and pull up my trusty browser here and say localhost :8080. And there we go. And it did refresh, and that is running. And so hopefully this gives you a distinction. Like, you know, again, back to Christy's question about, well, when would you use a virtual machine? Well, or, you know, as opposed to a container, for something like this, would you really build an entire Windows server on its own hardware or spin up an entire Windows Server virtual machine to do this? And the answer is no, right? We would containerize it. And so this little teeny lightweight functionality that we have here that we're, you know, using in the lab is perfect for a container project. Okay, so one of the things that they were talking about, they also show us like, okay, well, the container's running. Well, how can I connect to the container, right? Well, what if I was to say Docker run, or I'm sorry, Docker exec -IT. So give me a terminal and make it interactive sample running and run bin bash. And so I am now actually logged in to the container. So what if I go to home/my app on the container here? And what do we see? Well, remember, our Docker file said that when we created this container, that we were going to copy some directories in here into our container. And the two directories were static and templates. And the file that we copied in was sample_app.py. And so here those things are. They're right here. Now, the state of the container, and this is something that always learners will ask this question. Okay, well, what if I want to change the title in the index? So let's go. Can I get in? Let's cd into templates. Oh, sorry. I'll cd into templates. And what if I vi index.html? Well, you can see the vi command is not found, right? So it looks like vi is not even on here because, again, we've got this really basic install, HTML. There we go. So the word I'm going to use here is idempotent, right? Which means this is just going to do the same thing. This container has one function, and it is literally running this Python web app, and it's going to do it over and over and over and over again. That's all it does, right? So if I wanted to change something, I can't simply I can't simply connect to the container and then try to make changes to the container. You wouldn't do that, right? And this kind of becomes confusing sometimes, is that the container is going to run until it stops. And you would have to stop it, right? You'd have to kill the container, and I'll show you how to do that. You'd have to stop the container from running, and then you would make your change to it, and then you would start the container back up, right? So if there's anything you wanted to change with a container, you would have to stop, make your changes, stop the container from running, make your changes, just like when we ran it as an app, right? I went into the file. Remember, I went into the file and I changed what I wanted the title of the tab to say, and it didn't take. It didn't take until I quit the Python web app and then restarted it. And the same is true of the container. You would not you don't go on to containers and then start making all kinds of changes, right? And this is a good segue into something we saw earlier, which was the CI/CD pipeline. So who can tell me what CI/CD pipeline stands for? And you can drop it into the chat. CI/CD pipeline. You guys still there? Is everybody still with me? Can you guys hear me? Okay. CI/CD pipeline. So not good guess though. Include. So not so much include. So it's continuous integration, continuous deployment. And what that means is, and you'll hear it used in the sense of a CI/CD pipeline, and that is, how do you go from your code to a container or an application that's running, right? And so part of the CI/CD pipeline would be, we would make some changes to our code, we would check in, right, or commit those changes, push those to GitHub, and then you could pull down that code like you did for your project and run that code, right? And so that's kind of, a very simple, it's missing a number of components, but there's a good graphic in the text. Is when you start to read about the CI/CD pipeline, it'll go into more detail. But it's kind of the same concept, right? And to get off of here, I just say exit. So I'll just type in exit. And now I'm back out here on my CLI. But remember, my cool app is still running, right? So I'm clicking refresh. It's still running. Because, again, we killed that one there, right? That was actually taking the port up. Okay, so your app is running and you decide, hey, you know what? This isn't working for me. I don't like that it says my cool app. So I want to change that. Okay, well, how would we do that? Well, let's go ahead and say Docker stop. And here's where you would put the container ID if you did not use that little dash name thing, right? Which is pretty cool, because now I don't have to figure out, do a Docker PS, get the container ID, and then type that in, copy, paste. I know it's called sample running. And so I hit enter, and we're going to see that it'll take a couple seconds, and it's going to stop my application from running. Now, once the application is stopped, I can check by saying Docker PS, right? Show me what is running. Okay, well, we've got the Ubuntu thing we were messing around with earlier on, and no big deal there, right? So what if I said Docker stop? And I guess I'll give you an example. So if I wanted to use the container ID, let's copy the container ID, come over here, let's paste the container ID in. And then that's going to stop my Ubuntu container that I was messing around with. It's still running. All right, so after this, I should be able to say Docker PS, and nothing is running right now. But if I say Docker PS-A, this is going to show me things that were running that are no longer running, right? And sample running, oh, there it is. Oh, hold on, I lost my mouse. There it is. So sample running, right? So that shows us that it got created 10 minutes ago, but it's no longer running, right? We exited 44 seconds ago. Okay, so I've stopped it. All right, well, the container is still here. Remember, if I say Docker images, that container sample app still exists. So if the container's there, right, I want to remove the container. So I can say Docker RM sample running. Again, another advantage of being able to use the name as opposed to the container ID, right? And so now when I say Docker images, oh, whoops, sample running wasn't there. Docker PS-A, sorry. Say Docker PS-A, the image is still there. But when I say Docker PS-A, you can see that it's gone from here, right? So that removes it from the output that we see here, showing containers that have stopped. Sorry about that. It doesn't get rid of the image. There's another way to remove the image. So, okay, now what if you wanted to change something that was there? Well, now that we have that bash script, right, and we have all these things here, let me just back out of tempdir. I'm going to say rm minus rf dot slash to make sure there's no mistake of the tempdir I'm talking about. And I'm going to remove it all. And I'm going to go into my templates directory. I'm going to VI the index.html. And again, the idea here would be, oh, I've either checked the code out or I'm making changes to it. Then we're going to commit this. So we'll change the title here. I want to say something different. So I'll say some cool app, right? And we save it. Now remember, I need to create that temp directory. We want to create that Docker file that's in there. And to do that, all I have to say is sample-app.sh. Hit enter, done. Temp directory is there. So if the temp directory is there, all I would need to do is cd into the tempdir. Oops, tempdir, sorry about that. Cd into the tempdir. And now I can simply do the same steps that I did before in order to build the Docker file, right? Which is, we're going to go ahead and say Docker build. Whoops. Docker build minus T. And I believe it was sample app, if I'm not mistaken. Yeah, sample app. And we'll use the Docker file that's right here. Now, it went a lot faster that time. And the reason it went so fast is because, remember, the Python image was already pulled down. So that Python image was already there, right? All right, so we've got sample app again. So we did our Docker build. Now we're going to do our Docker run. Docker run, oops, sorry, I misspelled it again. Docker run, and we're going to say minus T for the terminal. We're going to say minus D to detach. We're going to say minus P for the ports. 80, whoops, typo. minus D minus P 80 colon 80 or 80 colon 80. And we'll give it a name and we'll call it sample running again. Sample app. All right, and there we go. So now when I say Docker PS, there you have it. And so that Docker container is now running. And as long as that container is running, I should be able to come over here to my browser and click refresh. And look at that. It changed the title, right? Again, I could have changed this text here, could have done whatever I wanted to. I could have changed the background color by manipulating the style.css file. But the key being is that now that it's running, any changes that I'm making I'm going to have to shut it all down, wipe it out, recreate the container. That way it's got the exact files it's supposed to have, and then everything is ready to go. And again, I'm getting rid of that whole temp directory and just redoing it so that you can see the steps that would be required, right? You could go into the temp directory. You don't have to delete that temp directory, the temp dir that gets created. You could go in there, modify the style.css and the index.html. And then after you've quit and got rid of everything, all your containers, you could just recreate the container, right? Build a new container and then run the container. And so that is how you use Docker. That is how you create containers. And to show you guys a quick example of what you could do, right, is you could do something like this. And so you guys will learn about RESTconf in module 8. And so this is a Python Flask web app. And you can see I've put some work into the style.css. So we've got these, table headings, and you've got different tables here. And so what this is doing is every 15 seconds, it's going out and it's connecting to a CSR 1000V. That is a virtual router. In fact, that virtual router is, where is it? I got too many. There it is there, but I need it there. And so here it is, right? And you can see all the little log messages there. It's saying the authentication pass, and there it is again, right? It's making these RESTconf GET requests to get that information. And so watch what happens if I go into global config and I say interface loopback 1. And I say IP address 1.1.1.1, and we'll make it a /32. And I'll even throw a description on here, my loopback 1 interface. So over to the right, look in the background on the web page and take a look at what just happened. It's auto-magically updating the web page over here. And it didn't have the description when it caught that the interface was brought up, because it took me a second to type it in, but there it is, right? And so here's a Flask web app using Python, not doing, anything too complicated beyond what you guys have already seen. And it's got this little, you think of it as a network operations center, has a dashboard here, and it'll see if the interface is up or not. And if the interface goes down, it'll change it to red. And so if I say shut to shut the interface down, the next time it goes to refresh every 15 seconds, that should say false and turn to red. And if you're sitting in your operations dashboard watching this, you would be like, hey, something's wrong, right? So and this is just to give you an idea as to some of the things that you can do with a Flask web app, right? With Python. All right, what questions do you guys have about what we covered in terms of going through our Docker stuff? And actually, I forgot, before we do that, let me give you the one Docker command here that is going to wipe out everything you see. And so I think this is the commands: Docker prune, Docker system prune, Docker system prune. So if you wanted to clean everything up, you would say Docker system prune -A. And that's what it's going to do. It's going to stop all containers, get rid of everything, I believe. Let's see if because we got a container running right now. So let's see what happens. All right. So it looks like it reclaimed some space there. Let me say clear. And let's do Docker images. I think the images are, so I guess it's only cleaning up what is not running or that are in use. Let's see here. So that, oh, it kept the sample app. Let's see, Docker PS. All right, so sample app and sample running is still going, but everything else that wasn't being used is gone, right? So that's a pretty key command there, right? Docker system prune -a, and that'll clean up everything that you had that's not running so that if you got a whole bunch of stuff running all over the place, you can quickly clean it all up. So what questions do you guys have? Any questions? And I know you're going to dig into this week, and hopefully it'll make more sense.